Okay, so for those of you watching the video, you can see the answers to questions 4, 5, and 6 on the video now. So now let's talk about the metric system. The metric system is the foundation for what we use in science. And it's a different sort of system because everything is multiples of 10. Here in the United States, we use the English system because our first founders that got us going mathematically were British, and in England, they still use the English system. Throughout the rest of Europe, they use the metric system. So the metric system has base units with decimal multipliers, and all are factors of 10. And I always think it's funny when students take their first chemistry class and they have to learn this, because today most young adults in the United States really have had no exposure to the metric system. When I was in about the 5th grade, the United States and Canada agreed that they would switch over to the metric system, and they were going to do this in a 3-year process. And Canada switched over. So if you drive across the border at Port Huron into Sarnia, you see all the road signs are in kilometers. But they started labeling things across the United States in both kilometers and miles during that transition when I was in like the 5th and 6th grade. And then all of a sudden the United States road people said, well, this is going to be too expensive. So the United States backed out and did not do the dual signage, and Canada went and switched over. So I always thought that was kind of interesting. And I thought it was quite exciting when I bought a car quite a few years back, and on my speedometer it had both kilometers and miles per hour. It had kilometers per hour, because before that it only had miles per hour, and when we would go to Canada, I'd have to sit there and do the math in my head to see if I was going to get stopped for speeding in Canada. Now I can just look down. I don't have to do math while I'm driving. So I think it's kind of interesting, and I think once you get accustomed to it, you'll like it because everything is the same. It's always multiples of 10. Whereas in the English system, there's 5,280 feet in a mile, but there's 12 inches in a foot, and so everything is just weird, and it's not some same unit. So these are the base units we're going to work with. We measure length in meters. Now that's a mistake because of Microsoft Word. It's a lowercase m is what we use for meters, is a lowercase m. Mass, we measure in the gram, and it's G, again, a lowercase g. Word likes to capitalize, and I didn't catch this until later. Volume is in liters, and we do use the uppercase L. Time is in seconds, lowercase s. And the amount of substance, we use the mole. Now, the mole is M-O-L-E, and we'll talk about the mole more as we go along. The abbreviation for mole, because mole starts with M, we can't use M because we're using that for meters. The abbreviation is MOL. And I remember when I first learned this, I'm thinking, really? We take off one letter and we call that an abbreviation? However, you'll see me write MOL because it does save a little time writing one less letter. So you'll see me write MOL quite a bit. Now, when we are converting within the metric system, everything is exact numbers. So when we talk about using conversions, if I say there are 100 centimeters in 1 meter, that's exactly 100. Even though it'll be written just as 100, perhaps without the decimal point, those are exact numbers, and we get infinite sig figs. And then we can combine the decimal multipliers and the base units to give us new units. So if you look in the middle of this page, you'll see we just have base and there's nothing written there. And this base can be anything. It can be grams or seconds or meters, whatever you want to use. Then we have units that get multiplied to make them bigger than the base. So if I go bigger than the base, the first one is deca, and we symbolize that with DA. And deca is 10, or in scientific notation, 1 times 10 to the first, or just 10. Hecto is There's no R on that. Hecto is 100. Kilo is 1,000. And mega is 1 times 10 to the 6th, 1 million. Now, I think it's funny, when I started teaching 23 years ago, most of my students recognized kilo because computers were starting and they had kilobyte hard drives, and they recognized that. Then along the way, everybody started to know what giga was before they came to class. Now, how big is your hard drive on your computer? Tera, right? You have a lot more storage. It's way bigger than the first computer I had that ran off 2 6-inch floppy disks. Okay? You put one in to run the system and one for your word processing files. Okay, I still have it. I don't use it, but I couldn't get rid of it. I just thought it's awesome, so it's sitting in my house. And then peta, 1 times 10 to the 15th, exa, 1 times 10 to the 18th. These guys, the big ones, are seldom used for us in chemistry. But down here, the ones we use a lot are giga, mega, kilo, not so much hecto and deca. And then going the other way, we use these a lot more because we're using smaller conversions. So deci is 1/10 or 0.1, centi, 1/100th, milli, 1/1000th. These are the three that we use an awful lot in chemistry. We talk about milliliters when we measure, 1,000th of a liter. Nano, 1 times 10 to the negative 9th. And then pico, 1 times 10 to the negative 12th. Femto and atto, negative 15 and negative 18. We use pico and nano a fair amount, but not nearly as much as those. Now, you notice that I skipped over the angstrom. The angstrom is a special unit named for the scientist who thought of this. So 1 times 10 to the negative 10th, and we use this uppercase A with a little circle on it. And it's because it came out of the German alphabet. That's why. So it's a little bit weird to us, but that is something that's used quite a bit when we're talking about the size of atoms or the size of ions. They will measure them in angstroms instead of 10 to the negative 10th meters. So let's go ahead and look at using some of these. And on the test, what you'll see is that I will ask you to change from one unit to the other, just like we're going to practice right now. So the new unit is gigameter, so we put giga and meter together. So we put the uppercase G and then the lowercase m is gigameter. And the relationship, giga, means 1 times 10 to the 9th. So 1 gigameter is equal to 1 times 10 to the 9th meters. Now, sometimes you want to go the other way. And if you are comfortable with exponents, this might not be a big deal for you. If you're not accustomed to working with exponential numbers, this may seem a little weird at first. But if there are 1 times 10 to the 9th meters in 1 gigameter, that's a lot of meters, right? Because giga is bigger than the base. Then 1 times 10 to the negative 9th gigameters is equal to 1 meter. So this is a very small number of gigameters in 1 meter. Now, most of you will probably feel more comfortable with this. Occasionally, I think of it this way if I'm trying to figure out what 1 meter is. Okay, let's look at kilogram. I put kilo, gram, right? So, gram is the base unit. Now, when you're learning the metric system, sometimes it's helpful to relate it to something that you know. Do you know how big a gram is? Do you know any everyday object from your life that has a mass of 1 gram? I'm always a little nervous asking this question. The thing I come up with is a paper clip. Okay, a standard metal paper clip has a mass of about 1 gram. I'm talking about the little paper clips, not the giant ones. But about 6 years ago, I asked my class, do you know something that's about a gram? And one of my students, it's always the back row. One of the students in the back row says, well, I don't know about 1 gram, but a nickel bag of wheat is 5 grams. Like, all righty then. Thank you for sharing that with the class. That was something new I learned. I could go home that day. I'd learned something new. So, okay, I got to tell you this. I'm going to stop the video.